Hello and welcome to our Tuesday live session. This is our first ever Stormwater School live. Obviously, last week was Wastewater Wisdom, and as we said, this week would be Stormwater School. So answering all your questions and queries, all related with stormwater management. And I'm joined today by my colleague Lisa, who's up in Scotland. Say hello, Lisa.
Hi, how are you doing?
I'm good. How are you, Lisa?
Yeah, very well, thank you. Excited to be here.
Very good. So this is the first time we're kind of doing this remotely. We usually have it here in the studio, but it's thrown up a bit of, not a bit of a challenge, but we have Lisa obviously up in our Glasgow branch, and I'm here down in Banbury. So doing this remotely, all things that the pandemic has taught us is that we can do it all remotely live over Zoom if needs be. So today's session or Stormwater School session is all about the step-by-step process of a stormwater project. So we're going to talk about what happens from the initial inquiry that we receive all the way to our team on site installing the tank. So without further ado, Lisa, take it away. What is the step-by-step process that someone would go through with a stormwater project?
Well, obviously, it starts with the inquiry. First thing happens is that we send a drawing mainly. We have a plate system that's modular. It uses base plates and end plates. So it's really, really important that we get a drainage drawing to be able to match our product to the tank shape. The number of base plates and end plates can be quite seriously affected by the tank shape. So we take the drawing. We obviously look at the requirements, look at whether it's under a landscaped area, under a trafficked area, whether inspection's required, and we match the product to the best one in our range, basically. We do have to sometimes make little amendments to the tank shape or dimensions just to work with our crates, which are an 800 by 800 square. Got little models here to show you. And we come up with a solution that works with our product range. So once we've put together a proposal, we value engineer it as well wherever possible, look for ways that we can, make it better. Our crate system has a really high void ratio as well, so we can often take quite a few metre cube off of the tank compared to what's drawn and give the same storage volume because of our excellent void ratios of 96 or 97%. So we've put together the best proposal. Obviously, one of the sales team will do a quotation and send this over to you with, a bit of detail on what we've sent, along with our spec sheets and our standard drawings for you to be able to check the technical specifications of the tank. Assuming that you're happy with what we've put forward, you would contact us and let us know, place the order, and we would at that point do a site-specific drawing based on our system, which we would send back to you for approval. Our technical team would put together, would do technical calculations and do a drawing showing exactly how the crate would look in our tank. We would send this back to the customer for them to sign off and approve and just double check if they're happy with everything before we proceed any further. We usually need our approval back within about 2 to 3 weeks of us going to turn up on site so that we can then allocate stock, get deliveries organised, etc. And if you're happy with it, says if you're happy with the drawing we've produced, we'll schedule an installation date on site, and the team will then obviously arrive to do the install. We can do infiltration soak away installations or also attenuation tanks. So obviously with an infiltration, the difference being you're only surrounding the crates with a geotextile system. We would lay the geotextile, obviously use our crates, as said here, to, build the crate, build the tank size to whatever as we've drawn. We do require the contractor to provide us with a forklift driver to assist the installation, to get the crates into the excavation for our installers. And then once we've built the tank to the required shape, we'll obviously wrap it all up in the textile and seal it. We only ever heat seal our tanks. We also, with attenuation, it's the exact same process. The difference being you're adding an extra geomembrane to make the tank waterproof rather than to infiltrate. So it's textile and then geomembrane. We build the crates in and wrap it all up, and we heat weld it and give you a 30-year guarantee in those welds as well. We then leave the contractor, to sign it off. We, give them their warranty, a sign-off sheet to make sure that they're happy with everything on site. And then we come away and it's the contractor's responsibility to then backfill the tank and obviously continue with the groundworks from there. We also have little pipe connection pieces as well, adapter plates so that we can easily connect up, twin wall pipe, etc. and vent to the tank system. It's really important to vent the attenuation tanks as well, so that the air has somewhere to go when the water comes in. It's quite a thing that people often ask us about. Obviously, venting it is incredibly important. So that's the process. It really is quite straightforward, and we are obviously there to help you, guide you through the whole thing as well.
Perfect. Yep, that was a very clear and well talked about explanation. Just a couple of questions with the excavation part. Is there ever times, or what would a contractor need to make sure the excavation is, or the requirements that we ask for in order for then our guys to go in and install the tank? Like, kind of what requirements are we needing for the excavation itself?
Well, as I said, we produce that site-specific drawing, so we require the excavation to be dug as per our drawing, but with a 500mm working border right around the end, so the guys can get into the sides and also do the installation. So that's really important, is to give us that 500mm of working room. We require the sites to be graded, stepped or graded, so that, and obviously safe and safe way to enter and leave the excavation. And the bottom needs to be prepared with a layer, at least 50mm, somewhere between 50 and 100mm of shingle or gravel, laid as flat as possible for the guys to have a nice level base to work on. We do think that a pea gravel or a pea shingle is the best material. It's really important that it's not too big so that it compacts well, but also doesn't have too many fines. Things like sand are not great because they can wash away and create voids under the tank, which obviously, is not good in the future when the tank is all backfilled. So something like a 10mm pea gravel is absolutely ideal. We can occasionally look at other materials if that's not available, but we need to be sent photos and everything like that, and our technical team would make a decision on whether the material is suitable. But the most important thing really is it's non-angular as well, because obviously we're dealing with sealed tank systems, and the whole purpose of these tanks is to store water. And so any bursts or holes in the membrane or textile is going to defeat the purpose of the tank. So things like sharp sand, etc., 6F2, these kind of materials are not suitable materials for a base.
Perfect. And when you talked about our tanks, we specifically make sure during install that they're heat welded. So what are the typical tools that we use in order to make sure the heat is, or what we use in order to weld the tank together?
The main thing we use is a wedge welder. Obviously, we overlap the membrane, and we use a special tool called a wedge welder, which basically, it goes into the two sections of the joint and then runs automatically down and seals the two together. We also do use like a little heat gun for things like the adapter plates, because obviously they tend to be on the side of the tank to seal the plastic together. But it's a specialist bit of equipment called a wedge welder is the main thing that we feel gives the best welds and so much better than tape. That is a common way to put tanks together, and certainly other people do, but the welding just gives us, we said go for this guarantee because we're very, very confident in it, and the wedge welder is the best tool for the job.
Perfect. I think, that's all the questions I know I certainly had during the explanation, and that's a very good, thorough explanation of the step-by-step process of when we first get the initial drain out or drainage layout drawing all the way to our guys installing the tank and then site backfilling it. So thank you, Lisa, for talking us through that.
No problem.
Next up is our project recap, some recent projects that we've worked on in the last few weeks. Obviously, last week we had David talking about the wastewater treatment system that they had to go sort out and some issues they had. But for this one, for stormwater, we've installed quite a few projects over the recent weeks, some fairly decent-sized projects with great stories behind. So we just wanted to share them with you. So Lisa, take it away. Can you see the first project on screen?
Not yet, no. Here we go. So this is Horton Fire Station. It was a lovely project, over 500 cube material in our EcoBlock Max with a row of Flex Inspect. So we have a Flex Inspect crate, which looks like this, as you can see there, which leaves channels for you to be able to run, cameras or jets through. The fire station is Horsham, is in West Sussex, and the old fire station has been replaced with a brand new facility and also combined in a big training centre as well. I'm sure you can imagine with this, it was very important that the tank could take heavy duty loading such as fire engines, and it was going to be trafficked over quite heavily. So we had to use a fully BBA'd EcoBlock Max with EcoBlock Flex Inspect heavy duty system. And it went really, really well, lovely install. So we were very, very nice job, and we're just very happy to be to be involved in that project.
Perfect. And the next one I think we have coming up is Stoke Mdu. So do you want to talk us through that one?
Yeah, absolutely. So this was actually Stoke Mdu, stands for Stoke Maintenance Delivery Unit. This was a job for Network Rail, for a contractor, working on behalf of Network Rail. The site at at Stoke had loads and loads of individual cabins and smaller buildings that were dotted all over the site, and so they decided to create this kind of one brand new facility combining all of the welfare, offices, etc. in Stoke. Again, with it being a Network Rail job, it was important that the tank was fully maintainable and inspectable. So our EcoBlock Flex Inspect was the best crate for the job on this one. It was really good as well because this tank was initially designed as an L-shape tank. As I said, because of our crate dimensions and our void ratio on this one, we could actually eliminate we designed it in such a way, we value engineered it, as to have to eliminate the kind of dog leg, the L shape. And it worked perfectly with our EcoBlock Flex Inspect, creating a nice, clean, easy to install rectangular tank. So we saved the customer quite a bit of money on that compared to others. So I think they were very, very happy with it. Really, really nice job. Also, it was very important as well that it was fully BBE approved, and of course our Max and our Flex are both fully BBE approved. That was just because it was a Network Rail job that was very, very particular in materials that could go into the site. So it was a great job.
Perfect. Sounds like a very good one, and especially since we're able to kind of save the actual kind of footprint of the tank with our superior void ratio with the EcoBlock Flex. And the next one,
sorry.
Oh, sorry, what did you say?
That's what I say, yeah, because it's not only obviously the saving on the crates themselves, it's saving on excavation, muck shifting, all this offloading of materials on site. So it's actually, the savings can be more than simply just the crate themselves. Yeah, absolutely. So the next one, Hatchley in Windsor, was 256 metre cube tank, I believe. It was a residential, new residential development, basically, in Windsor. We worked quite closely with the engineer and the contractor on this one. And again, we helped with the shape on this one. I mean, it still was an unusual shape in the end, this tank, but we really, really managed to, make it a bit simpler than it was. It was really quite complicated. As you can see, kind of on the left-hand side, there is like a corner there, an internal corner. But the tank, as it was drawn, was much more oddly shaped. So our void ratio meant that we could, create a more easily to install shape. And we kind of worked with the engineer to design this one as well with them. So we were quite involved quite early on. So it was a great job.
Perfect. So some really nice images of that. Very nice install.
Definitely.
Very nice. Very nice. So the next project we have coming up was one obviously very, very local to us. It's only literally a stone's throw, and some of our employees here live within a couple of the estate that this was in. So yeah, the next one was Hamwell Chase in Banbury, of all places.
Yeah, this was one we were determined to win because it was just down the road. Obviously it was so local to the main head office in Banbury that we really, really wanted to be involved in the job. Again, it was for a new housing development. It was actually a soak-away tank. This one was an infiltration tank rather than an attenuation tank. That 272 metre cube, like one of the big features was that was delivered on one vehicle. All of this crate you see was delivered on one lorry because of the stacking design of our EcoBlock Max. It's got a little model, which I don't know if you can see here. So we send this out on, trucks like this, all the crates all folded inside each other. When you get to site, you simply, obviously take one off the stack and give it a 90-degree turn, and it creates this, and they lock in exactly. So it means, though, that we can get a massive amount of crates on one vehicle. So that 272 metre cube with base plates and ends all came on one lorry, which was obviously, massive saving for offloading time as well, storage time on site. And it was a really, really technical project. Again, I'm sure you can see in those photos. This is one that the shape, unfortunately, we really couldn't be. It was dictated to by the side, the area, and like other services and everything in the way. So it shows kind of the skill of our installers to install this almost stepped tank. But a really, really nice job, one we were very proud of.
Yeah, it's a very, very nice tank. For one, it's one we're installing a soakaway and not an attenuation, so I'm probably glad they didn't have to do the internal corners. But there's a very nice tank, and obviously being it so close, it meant that a few of us were able to go down and see it being installed. So the next one we have is Brake Hall, Bedale. Some lovely photos coming as well.
Very, very nice pictures. A lovely day in North Yorkshire, it seems. Don't get many of those, certainly like Glasgow. So yeah, as I say, this is North Yorkshire as well. Another residential development, another new housing, and the village of Craig Hall, which is in North Yorkshire. It was an EcoBlock Max system. The site wanted to make sure, with it being a housing development, you might think, not heavily trafficked, but you have to think of things obviously like bin vehicles, which can be really quite heavy coming around every week, potential delivery vehicles. So they wanted something which was really capable of heavy duty loading on this site. So our EcoBlock Max, as I said, is BB approved up to 44 tonnes. When we constructed the tank entirely from EcoBlock Max. Good job, went very well. Customers seemed very happy.
Yeah, some very nice photos coming in, obviously, because you can't see on the screen, but there was some really nice blue skies. And like you say, there's not very much of that in Yorkshire at the moment at this time of year. So that, I think, is all for our project recap. We had some amazing jobs and installations go in over the past few weeks. Some really large attenuation and soakaway projects, as you saw, and a really good overview of what our engineers have been up to over the past few weeks. So we've had some questions come in whilst we've been live during the presentation. So we're just going to read them out to you, and then we'll get Lisa to answer them. So the first question coming in says, how do we put the side plates or the end plate on an attenuation tank?
Yeah, of course, really simple. So I'll show you first of all with our Max system. As I said, if we assume that these, EcoBlock Max crates are clipped together. So one kind of common misconception with our modular system is that you need to put side plates around every single crate. That is not the case. You only have to put them around. So you build your tank to the finished shape, and then you're just clipping them on basically the outer edges of the tank for a bit of stability. And also it stops the backfill. You can imagine when they're wrapped, if there's nothing, to make the sides a slightly more solid, the backfill can start to push on the membrane quite seriously. So you really only need to put these around the outside edge of the tank. And they really are so simple. Obviously, these are really to scale. Our actual ones do have graph written on the side, so graph should be facing up the way, and you're really basically clipping them right around the edge. It really is simple. It's as simple as that on site. They just push on. Our flex system is slightly different because our EcoBlock flex system, as you can see, does have two solid sides. Just the design of the crate has two solid sides. So if you're doing a tank which has EcoBlock flex along the edge or is made entirely of EcoBlock flex, you should be turning this as you go. For example, so if this was on the corner, the next crate here, you would turn to the side so that the sides there are solid, and then you're just putting end plates on the corners, basically. I hope that makes sense. But yeah, so if this was you would actually turn this here so that the next edge is from the crate, and you just put end plates on the corners. I hope that's clear. It's much easier. We're happy, obviously, give one-on-one discussions about this. If anyone really is a bit unsure, we can give a call or set up a video call and go through it a bit better.
Perfect. Now I think you did cover it quite well. So what have we got? Another question lined up. So what is the least and maximum amount of cover you can have on top of a tank?
That's a really good question. There really is. There's also an absolute bare minimum, which is 250 millimetres of cover based on absolutely no vehicle loading, not even a drive-on lawnmower or anything, pedestrian only. But the amount of cover you can have, minimum and maximum, is very much determined on the crate type. So we have a range of crates from light duty through to heavy duty. It's based very much on what type of loading that you need to require with that. For example, if you only need cars above the top, your minimum amount of cover will be significantly less than if you need to have articulated vehicles. And again, too much cover could also mean that the tanks are too deep and there's too much pressure on the sides of the tank from lateral loading. So we say an absolute maximum above the tank should be 2.75 metres. In our EcoBlock system, slightly deeper in a rain block, we can get 3 metres. But it is, the absolute minimum is 250 and the absolute maximum is 2.75 metres. But it's very site specific and dependent, and if you tell us what loading you're trying to achieve, we can further advise, or our spec sheets that we send out at quote will have that information on it about the minimum and maximums, but we can do site-specific calculations, Syria C680 calculations based on the levels on your drainage drawing and let you know exactly what load in the tank will achieve.
Perfect. I think that answers that one. We've got another question lined up. Can we have construction vehicles on site drive over the tank once it's been installed?
Yes, as long as the site do make it up, even if it's only on a temporary basis, as long as the site do make up the cover to a sufficient level to support heavy vehicles. So yes, that is something that can be, has to be considered certainly as construction load. And even if the tank is going to be a pedestrian area and it's finished life, is it going to have construction vehicles driving over it during the, the rest of the construction process? So we would, you do need to make the tank up to the correct level. Things like that is fine for vehicles driving over it. If there is things like cranes, that is something we need to again calculate if you're going to have cranes or outriggers bearing down on the tank. Something like spreader plates might be required, which will depend very much on the specifications of the crane, what weights it will be lifting. So yes, it is possible, but again, there is no one answer to that question. We need to look at the information you give us and we'll advise accordingly.
Perfect. So we've got another question coming in. What material would be needed to use as the base backfill of a Stormos tank during the installation?
Again, I think they kind of mentioned a pea gravel or a non-angular shingle is absolutely ideal. Very important it's non-angular, very important that it doesn't have a lot of fines in it or a lot of big sharp objects. So somewhere between 8mm and 16mm is fine. Non-angular 10 does seem to be the most common.
Perfect. Thank you for that. And I think my glamorous assistant has pointed out to me there's no more questions that have come in during the live stream. So I think that is that for today's Stormwater School Live. So thank you for your time, Lisa, and thank you for answering the main questions, going over the recent project that we've installed and answering all the questions that have come in during the live stream. And yeah, that is that. And thank you to everyone that is tuned in to watch. We hope you have a great week and we'll see you on the next one.
Thanks, Callum. See you later. Thanks, everyone.
Cheers.
Thanks.